Hello, everyone. My name is Ivan Sharmok. I'm a solutions architect at Tegera. And in today's session, we are going to look into enterprise security controls for Kubernetes platform. Here's a quick agenda for today's session. We are going to take a quick look at Calico, what it is, what it does, the Calico offerings, and then go through some of the security controls that offered for Kubernetes platforms in terms of standard, default, out-of-the-box controls, and what Calico can provide in addition to those. And in the end, we'll go through some demo scenarios. All the collateral, all the demo scenarios are available on GitHub. And I'll show you the repo as we go through. So first, what Project Calico is, or just Calico. That's an open source software developed by the community and maintained by the community that is designed to provide networking, network security for containers, virtual machines, and host-based workloads. We have a lot of people in the community that are participating actively in communication channels. Like Slack has over 5,000 members today. We have a number of people contributing to the project, and we know over 1 million nodes that run Calico on day-to-day basis. If you're interested or need help, please join one of those channels. The Slack is very active, very helpful when you are just starting or running into issues. And if you find any bugs or want to contribute, please do on the GitHub Project Calico project repository in there. You can always open up any issues and contribute there. So the Project Calico is known for being one of the best performing data planes for Kubernetes, and one aspect of that is it's been designed to set up layer 3 network without any requirement for encapsulation. In addition to those, Calico also offers overlays like IP and VXLAN, but they are not a requirement. So you can easily set up Calico networking on your Kubernetes cluster without any encapsulation, and therefore not be taxed for any overhead on that. It is quite scalable. We are using Border Gateway Protocol, BGP, to distribute the routes, and therefore the cluster that leverages Calico can be easily scaled to thousands of nodes or to limits of Kubernetes. Entire internet is built on top of BGP protocol. The network policy implementation that Calico provides has earned it to be a de facto standard for majority of distributions of Kubernetes. It's offered in the cloud providers and managed offerings like AWS, Google, Azure, IBM, or in packaged solutions too, with different variations of how it's packaged, either full Calico installation with networking and network security, or just network security, mix and match basically. And it's been running in large clusters. Some of our largest FinServ and tech customers and SaaS companies have been running Calico since early days of Kubernetes. So it's been tested and proven in very large clusters. As of today, we know of over 250,000 clusters that run Calico. To give you a brief visualization of how Calico spans in the industry, on the left-hand side, you can see well-known managed solutions for Kubernetes like EKS, GKE, AKS, IKS. And moving to the left, upstream Kubernetes offers installation of Calico, Rancher, OpenShift, Mirantis, MKE, or VMware Tanzu. All of those offer you to install Calico into their package solution, and many others that are not necessarily listed in here, but pretty much any known packaging either supports out of the box or offers Calico to be installed. And moving all the way to the right, where you can run that in on-prem clusters and also get outside of Kubernetes domain and run Calico on VMs and bare metals that may not be necessarily a part of your Kubernetes cluster. So let's take a look at the security controls that are offered for Kubernetes in general. To start with, I want to go through basic Rbac or role-based access controls, where we have three main areas that Rbac is based on. You have subjects comprised of users, groups, and service accounts, operations that represent a list of operations that can be done to resources, such as pods, nodes, and so forth. In the subjects, only service accounts are a part of Kubernetes platform where they created and managed within your Kubernetes platform. Others, like user and group objects, they typically come from identity management systems through some integration, like identity provider. The operations can be applied or matched to one of the subjects using roles, and role bindings then provide the means to link those operations and subjects to what resources the actions can be performed on. The topic of Rbac on its own is quite large. You can dive in there and spend a good hour just going through examples. So in here, just a high-level overview of what it is and what it's used for. It's worth noting that Calico leverages Kubernetes Rbac to provide access to its resources, and in Calico Enterprise to manage some of the resources using UI. The Kubernetes network policies that provide means for administrators, developers, operators to define security rules for deployments for workloads that are running in Kubernetes cluster. They provide a declarative way of creating those network security policies. The policies themselves enforced by the CNI that you install on your Kubernetes cluster. So that's CNI plugin that does the enforcement and has to implement network policy APIs or specification to enforce, to provide you with the ability to deploy and enforce the policy rules. By default, Kubernetes network policies are namespace scoped, and that's the only option you have today, which means that any namespace by default does not have any policies. You need to make sure to provide means of deploying the policies as you create in namespaces, especially if you're trying to achieve the zero trust network security in your Kubernetes clusters. Policies use labels and selectors to apply security rules to the targets, endpoints on the pods, and can provide rules to and from namespaces, pods, IP blocks. You can, within the security rules, you can specify the protocols that Kubernetes today supports: TCP, UDP, and SCTP. That's been added in version 1.19. It's in beta release right now. And you can specify the ports and port ranges within those rules. The rules that you can create within the policies, called ingress and egress, that's your to and from direction. And by default, if you do not have any policies, the traffic is allowed. Any pod can communicate with any other pod. But once you apply a policy that targets specific endpoints, only what's defined within those policies is going to be allowed. Anything else is going to be denied. And we'll take a look into that once we get to the demo. Calico network policy is a superset of standard Kubernetes network policy. It extends the capabilities provided in Kubernetes network policy specification. You have ability with Calico policies manage some additional metadata, some additional fields that allow you to order those policies, to provide L5 to L7 match rules combined with integration with Istio Envoy. You can apply policies to the VMs and host interfaces on those VMs and bare metals, which allows you write policies to not only govern or your pod-to-pod traffic, but also protect the host endpoints. And Calico also provides the ability to create global scoped policies where you can create a single policy and target all of the endpoints within your cluster. That comes handy, especially if you're implementing something like zero trust networking and write a default deny policy. We'll also take a look in the demo. There is an example for this scenario. Calico provides you 4 actions that you can define within your policy rules: allow, deny, log, and pass. In standard Kubernetes network policy, you don't have any action. The implicit action is allow whatever is mentioned within the rule. With Calico, there are some additional ways you can leverage the network rules, and we'll take a look into those, especially pass action that comes into play in the enterprise version. And Calico also provides the ability to specify, to select for service accounts within the rules. So in addition to just targeting endpoints and namespaces, you have an ability to be very precise on which service account should be used within the flow in order to allow that rule. When it comes to the enterprise version, there are some additional capabilities, and a few of those, just to list in here, a few DNS policies, policy tiers that allow you hierarchically structure your policies within the cluster, policy impact preview, and policy staging, something that is quite often used by our customers. One of the standard approaches in Kubernetes platform is to implement zero trust security. And zero trust typically starts with deploying a default deny policy everywhere. And it's possible to implement it using both Kubernetes standard network policies and Calico network policies. The difference would be just in the way you would approach it, how you would implement the process for enforcing that. Once you create a namespace, you need to make sure that by default, all the connections for that namespace are not allowed, and you would start deploying the policies to allow the connections for your workloads. With Kubernetes, each namespace needs to have a default deny policy, meaning that you need to define a process in which you create a namespace and right off the bat, you would deploy default deny policy. With Calico global network policy, you can achieve that by just deploying a single default deny network policy onto your cluster that will target all the namespaces regardless whether they exist or they will come later. And it's important also to make sure that your default deny is implemented in the right tier when you're working with Calico Enterprise, because the precedence matters in the hierarchical structure. So if you deploy that too early in the evaluation chain, then you can unintentionally block a lot of traffic downstream. So in terms of security controls that Calico offers, in addition to standard controls offered by Kubernetes out of the box, you have ability to deploy network policies and network sets. Each of those types is each of those resources has a counterpart prefix with global, meaning that's a cluster-wide resource. There are policy tiers allowing you to create the structural hierarchical structure for your policies. There are such features as global threat feeds, global alerts. You can generate compliance reports for compliance teams that becomes very useful to prove the compliance within the cluster. And threat defense capabilities such as intrusion, anomaly detection, automated packet capture. In terms of alerting capabilities, here's a quick look at some of the logs data that is leveraged for the alerts. We capture flow logs, audit logs, and DNS logs, and you can create respective alerts for the data captured within those logs. In the compliance reports, we also have a visual representation of those reports, and you can export those. They are captured in comma-separated value format. You can export those because each of those contains a lot more data than what's visually presented in terms of just endpoints, how many of those covered, how many are covered by policies, how many do not have those within the reports themselves. There is a lot more data. So you can easily export that and ingest into other systems or provide that as a report for the audit review. In intrusion detection and anomaly detection capabilities and threat defense, you can easily block bad actors, and we'll take a look at the example using a global threat feed, identifying malicious activity, anomaly detection. If we have enough time, we'll try to go through that scenario as well. Create a moat around some sensitive and critical workloads. There is also honeypot capability that allows you to create this luring pods for intruders to, once they hit that pod, we trigger the deep packet inspection on that. You can trigger packet capture. So they allow you to create this, to set out traps all around your Kubernetes cluster, and watch if any traffic hits that, you'll get alerted, and we'll produce some additional data capture around that to understand what's happening. With all the tools that Calico provides, you can easily automate and mitigate any security incidents. Some quick takeaways from what we just discussed. The Kubernetes network policies enable you to declaratively segment your Kubernetes deployments and the connections between those deployments. With Calico network policies that provide additional capabilities, you can solve real-world use cases using additional features that Calico policies provide. Calico has been proven in very large-scale production deployments. It is easy to implement and maintain. With the security controls that Calico provides, you can easily fine-grain and coarse-grain access to your workloads and external services. The security teams can get notified of any unsanctioned activity. The compliance teams can generate reports to prove the compliance, and threat defense, intrusion detection capabilities allow you to be proactive and detect and act on any malicious activity. If you're interested to try out Calico Enterprise, then we offer a few options where you can request a cluster that will be built for you to use for a few days, or you can start with a hosted solution where you can upgrade your existing cluster to Calico Enterprise and run that for extended period of time, just testing out different solutions. We also supply some guided labs and scenarios where you can go and try out different use cases. We published recently, Kubernetes Networking ebook, which is available for free. You can head to one of these links. The presentation will be provided after the session. You can find the information in there. And also there is Calico certification course, which goes through very basic scenarios to some advanced scenarios. We got pretty good feedback from people who've taken the course and try to understand how it works, what they can achieve with it. There are these sessions like this we run on monthly basis. There are a few per month. So here are a few upcoming sessions where we'll provide some insights into how to use Fortinet with Calico or any cloud where Kubernetes can run. Multi-cluster management capabilities that Calico Enterprise provides, like federated identity and services. Quite exciting topic, as you can solve very peculiar scenarios with that capability. We have a session on how to protect your clusters against unpatched Kubernetes vulnerabilities. And here is a specific example of the CVE that recently came out and how you can build a future-proof security for your Kubernetes clusters using Calico policies. And so a session on the security and observability for Kubernetes networking. So let's jump into the demo. And before I do that, let me review the questions. First question, what's the recommended way to understand what rules are applied by Felix for a specific resource, be it pod, VM, or host endpoint? I will show this during the demo. And what are the network sets? I will also stop on that once during the demo. So let's jump into the demo and cover this as we go. So for the demo scenario, I have a cluster which runs a few workloads, and let me show you what I got in my cluster. I have two namespaces, NS1 and NS2, where I run a few workloads, like a utility pod. In one case, it's CentOS and Nginx deployment with a few replicas. And in the other case, it's NetShoot pod and also Nginx deployment in there. Let me bring up the repository. So all the examples that I'm going to use for the demo are on the GitHub at Tegera Solutions account and in the repository Calico Security Controls for K8s. And I have pre-deployed some of this already just to save on time, and we'll go through a few scenarios in here. So one of the examples that Calico provides, especially Calico Enterprise, that's the ability to deploy staged policies, where you can deploy a policy in a permissive mode. So before I do that, let me quickly show you what Calico Enterprise interface looks like and what information you can get from here. So the first thing that you would see once you get into the UI, that's information about connections, bytes allowed, bytes denied, bytes, the number of policies, total number of endpoints and nodes. And these are the nodes known to Calico, not necessarily your every single Kubernetes node, which is included in there, but also there could be nodes that are defined that are outside of the cluster, just VMs or bare metals, and added, defined with Calico as a node to which network policies can be applied. And that's an extended capability that Calico has, where you can install a Calico as an agent, as a service on non-Kubernetes node, and then apply Kubernetes policies to those nodes to program the firewall rules in there. And there is a packets by policy histogram that shows you a live evaluation of policies that you have defined in the cluster and how the traffic is moving through those policies. So if you hover on any of these bars, you would see the name of the policy and some information about the packets moving through that policy. And you can notice that in some cases the name of the policy has .staged in there, meaning that is a staged policy. So in our example right now, we have 2 namespaces where we have workloads defined. Right now, there are no policies for any of those, so all the communications are allowed. Let's deploy a staged default deny policy just to show what would happen if you create a staged default deny. Let me launch a few commands just to curl to get logs from each of those utility pods. So here's from CentOS. We can see that CentOS pod is curling the Nginx service in its namespace in a loop, and netshoot is doing the same. So at the top right, that's my CentOS. At the bottom right, that's my netshoot. So once I deploy the stage policy, you would see something like this. The red bar shows up that the traffic, some traffic would be denied. But at the bottom, you can see that denied bytes and packets are not showing up. And if we hover over this, we see that this is a staged policy. So this provides you means of seeing what could be happening in the traffic, and evaluation, and showing you that staged policies would deny traffic gives you a clue of what could happen if you were to enforce this policy. So right now, I'm seeing this in here, and I can hover and see what that policy is. If I click on that, I get to the policy itself, where you can see some information about the traffic moving through this policy, through different rules, the information about what this policy is applied to, the main selector in here, and you can see this is a global policy. The scope tells us where that policy, whether that's policy for a specific namespace or cluster-wide. And in my example, I want to limit this to certain namespaces. Otherwise, if I don't do that, then it's going to be applied to the entire cluster. And I'll show you a few examples of what could happen if you deploy a policy that is cluster-wide and you don't have the policies that allow necessary connections. So in my example right now, nothing got changed except for the fact that now I have the tools that Calico provides show me what could happen if I were to enforce this policy. And if I jump to the policies board, which shows me the policies and select all of the policies in my cluster, I can see there are some staged policies. You can see the staged badge defined for each policy that is staged. In this view, you can also enable some additional metadata and see how traffic moves through each of those policies. And if there is any traffic that is denied, that becomes gives you a quick cue to see what policy can be denied the traffic, and then you can start jumping into there to see what's happening. But in addition to this, there are additional tools that can exactly tell you which policies were applied to which flow. And then you can investigate why the traffic is getting denied. Each of the policies has a number of endpoints that it applies to. That also gives you a cue how wide the policy gets applied. So you can see some of these policies have like 40, 45 endpoints, and that's my allow kubedns because most of the services in the cluster need to access that kubedns. So let's apply the default deny that would enforce the security rules. So in my example, the first one that I applied in here is stage policy. Here is the YAML and how that looks in the YAML file. We have the kind that says staged global network policy that's of type Calico. It's a Calico API that implements it. And I have an order that I've set up in here to 2000. By default, any Kubernetes policy, because Kubernetes policies do not have the support for order field, every Kubernetes policy gets an order of a 1000. In Calico policies, if you don't specify anything, then you would be on the same range. But you can move those upper to be preceding to any Kubernetes policies if you start adjusting this order. You want to make sure that your default deny acts as a catch-all. So any policies preceding that would evaluate the traffic and decide whether traffic should be allowed or maybe explicitly denied. But this default deny would catch anything that is not allowed and therefore not allowing any traffic for which there is no explicit rule allowing it. And you can implement default deny with using just Kubernetes network policy. So you can see the networking KDS.io that tells us the API for this network policy is Kubernetes standard. And example of how it's applied, you do specify the namespace because each Kubernetes network policy must be assigned to a specific namespace. So let's implement this policy now. So once it applied, you can see the CentOS pod stopped getting the response from the Nginx. And if we jump to our policy dashboard in here, in a moment, once we get the new data, new red bars should start showing up for the traffic being denied. Here it is. And you can see the bytes, the denied bytes at the bottom chart starts showing us that some traffic is getting denied. So in addition to these tools, there is also flow visualization tool that shows you all the connections between the endpoints within your cluster. In this representation, we have 3 concentric circles. There is outermost, which represents your namespaces, then the middle circle that gives you the deployments, the workloads names, and the innermost that gives you point-to-point connections. So if we filter down to our NS1 namespace where we just applied the policy and take a look at it, we see the traffic. There is some red line blinking in there. And if we switch to status, for instance, we can clearly see that there is a denied connection. The status view gives you binary format where you see either denied or allowed traffic. And if we hover over this, you can see on the right-hand side, the information changes showing you which policies apply to this flow. And if any of those policies denies the traffic, you would start seeing those red triangles showing you whether the ingress is denied or egress is denied. So that comes to the question that was asked, how you can see which rules getting applied. And if you can see that easily without getting to each node, you can always hop to the node, but you can imagine if you have hundreds of nodes or even tens of nodes in your cluster, that's not very practical to go to each of the node and check the rules on those nodes to understand what's happening. So with these tools, you can easily see on each flow which policy applies to which flow. And even if you want to look further and understand every single detail in there, we also provide additional information. You can look into raw flow logs that we are capturing. I'll try to stop on that a little bit later in the session. So now let's implement a few rules to allow the traffic to go through. And before we do that, let's confirm that we can what we can curl. The first line makes a request from CentOS pod to Nginx and cannot go through. The second from netshoot to respective Nginx service within the namespace, and that still goes through because there is no policy that blocks the traffic in there yet. There is only stage policies, but it's deployed as in a permissive mode. So let's deploy a rule to allow a policy to implement necessary rules for CentOS to go through. So now you can see our CentOS pods can curl Nginx. The only change in here is that now we are allowing only connections defined within this rule. So let's take a look at that implementation. And in here we have two policies. One allowing ingress for Nginx, and we define the pod selector. That's the top level selector. That's the main selector. Tells you to which targets, to which endpoints the policy applies. And then within the rules, you can have additional selectors like pod selector and namespace selector that tell you either from or to which endpoints the traffic should be allowed. As you can see, there is nothing that says in here, allow this connection or deny it. It's an implicit value of allow for any of the rules that you define in here. And for second network policy, it's egress that applies to CentOS pod, and that allows the connection to Nginx. And why I need to implement egress, that's because I've implemented default deny policy. If you do not have default deny, that then you can get away with just ingress rules. But once you implement the explicit policy that denies both directions, then you need to define policies and rules for both ingress and egress. It's always easier to start with just ingress rules and deploy something like staged policy to help you understand which traffic can be blocked. And once you get to the level that you're comfortable with writing both direction rules, then you can go ahead and enforce your default deny. And also staged policy is very useful in development and testing clusters where they do not necessarily block anything, but they give you visual cues of what would happen if some policies are missing certain rules, or if you're trying to simulate an attack. So now let's go ahead and implement our default deny. So we can do that through UI just to give you a feel for different way of enforcing the policy. So right now, this is my stage policy, and I can just go ahead and enforce it. Now it becomes an enforced policy, so I can filter out the stage ones. And if I take a look into the additional metadata, if I enable that, I would start seeing the traffic getting denied on the on this by this policy. So we can see right now that there is global default deny, the only red square, a red bar that is showing up in here. And we can still see the connections are getting denied at the bottom here. So now our request to the net should that previously was going through, now it should be denied, and we can see right here, we cannot get the logs for Nginx. And so in this command, actually a few commands are packed. NS lookup, we can do the NS lookup of the Nginx service within NS2 namespace. But the curl command is failing here. So let's go ahead and implement the rules, ingress rules for this one, and unblock it. Okay, so now it's going. Let's take a look at the implementation of those rules, because these are Calico network policies. So both of them implemented as a standard namespace network policy. We specify a namespace where it applies. This syntax is a little bit different on selectors. It's a little bit friendlier if you are a developer to write this. The syntax itself supports different combinations using logical OR, and there are some something like in operator that allows you to specify an array of different labels in there. You can basically mix and match different configurations in there just within one selector. Then you have the ability to specify the protocols and ports, similar to how you would get that in standard Kubernetes network policy. And you have this action where you can specify explicitly which action should be taken in here. There is another example in here to use Calico log, and I'm going to show you how the rule looks, but I'm not going to run through this just to save some time. So the action would just state log, and all what's going to happen with this is that in the kernel Linux kernel file, we would see the actions logged once it runs through this rule. So if you are looking to collect some additional details, especially if you're running Calico open source, where you do not have this UI because it's a part of enterprise product, you can still get some details just running the log actions and logging what once the rule is hit, logging that action into the kernel log. Going to skip Kubernetes Rbac. You can run through that example, and same as policy tiers. So for the policy tiers, let's take a look at what we have already in the cluster. In my case, I have 3 tiers in here. Actually, it's 4. I hit the allow Tigera. That's the tier where access to Tigera components is defined. For the other tiers, I have security platform in default. In the default tier, that's where you would typically put the network policies for your applications. If you enable developers to create policies themselves, like create a self-service, which with Calico tools you can do that, then all the policies developers should be deploying that should be into the default tier where they apply to their applications that they work on. And through using Rbac, you can give them access to just deploy only, let's say, staged policies and do not deploy any policies that would enforce the traffic right off the bat. And give them access also to the UI just to manage their policies that they have access to. In preceding tiers like platform and security, you can create guardrails. Like in security, you can create a quarantine policy, which you can use, security teams can use to, if there is an incident, security incident, and there is a malicious pod, they can label that pod and get it quarantined right away, and then investigate what's happening, what that it's trying to do. In a platform tier, you can define something like allow kubedns access. And to give you an example, if you do not have necessary rules in place before you apply something like default deny, here's an example of what could happen. We have already deployed the policies for our NS1 and NS2 namespaces, so we have access. But if we did not have the allow kubedns policy deployed before the default deny is enforced, here's an example of what could happen. Let's edit this policy and include in here our two namespaces, NS1 and NS2. And here's an example of the operators that you can use with Calico selectors. So from what I'm doing in here is excluding from allow kubedns policy all the endpoints within this namespaces, Acme, NS1, and NS2. And if I enforce it, you can see the number of endpoints dropped in here, and my connections are failing now. And the reason that it's happening because my default deny is not allowing kubedns access. It's not explicitly defined within my rules for within my policies in here, but it is enforced and it is defined within allow kubedns. So I need to include those endpoints to allow them access to kubedns. And if you take a look at the kubedns, all it does, it says allow access to kubedns component using the label on that component, and it passes all other traffic. Here is an example of using the pass action. So in the preceding rules, since you're matching, this is a very wide rule. It matches everything but endpoints in this namespaces. So I want to make sure that I'm allowing only specific traffic, but everything else I do not block. By default, Kubernetes policies and Calico policies as well work in the way that only what's defined explicitly gets allowed, and the rest of the traffic, if there is no explicit action for that, it gets dropped, it gets denied. So the pass action allows you to pass any further traffic that this policy applies to, because it's a wide policy, pass that to the next tier. So the policies in the next tier can decide what happens to traffic that is not going to kubedns. And that's the reason why you need to be careful when you implement in default deny. You need to understand how it works, and the stage network policies is a good way of starting approach in the zero trust security. So let's exclude those two. So the network sets, another question that was in the chat. Network sets represent a group of a list of IP blocks or domain names, where you can then decide and design what is happening, how to manage access to a list of IP blocks or domains. Let's deploy a few and take a look at this. Okay, so there are public nets and there are allowed external domains network sets that I deployed. Let's deploy let's try to curl, actually. Let's get the IP address from Apple and try to ping that IP address. So if I get that IP address, I can ping it. It's all fine. So now I can use a network policy to reference my public nets list and control what users have access to. So if I deploy this policy and try to ping the my public IP again, now it's getting blocked. And the reason it's doing that, let's take a look into the policy. Here is my deny public nets egress. The rules that are defined in here saying that deny access to anything, any endpoint that has labels type public and list type CIDR. And that's for both TCP and ICMP. So if I get to my network sets in here and look into the public IP nets, that's my labels in here. And you can see the list of IP addresses specified in here. So you can group a number of CIDRs or IP blocks and then use the labels assigned to those network sets to apply policies. One thing to note in here, you can see the namespace currently says global across all of them, but network sets are presented in two types. The namespace one, like here, KSC Kubernetes, it belongs to the default namespace and global type. They work with respective policy type, meaning that the namespace can be specified for namespace policies, and global works with the global policies. And similar example goes for domains. Here's my allowed external domains. I have two domains defined in here. I'm using wildcard for subdomains of Google.com and just Google.com. So to show that, let's take a look at the example of Gns Policy. So if I, let's say, go ahead and try to curl Google from center spot, you can see right now the access is not allowed. That's because my default DNS policy blocks it, and I don't have a policy that explicitly allows that access. And the same would happen if I try to curl, let's say, Apple, right? So let's try to implement a policy to allow that access. So policy is implemented. Let's go and curl Google. Now I have access, but I still do not have access to Apple because my policy just allows Google. And if we take a look into the Google policy or the DNS access for Google, we would see that I'm listing domains right here in the policy itself. So if your policy just requires the access to a specific domain, you can do it right here. But if it's a list of domains where you have security team that vetted a list of domains and you want to simplify the management, that's where you can use a network set as well. So let's try to redesign this by editing the rule and removing these policies and instead using the label. So we'll take domain external, that's the label on my network set. Let's enforce this and take a look at the network set. Here's my allowed domains. Here's the label, domain external, which lists two of this. Let's validate that I still have access to Google.com and access to Apple.com is not available, right? So the easy way then becomes, once you manage that is network set, all I need to do now is just add in apple.com in here. And now I should be able to query Apple. Yes, so I got the access to my Apple. That's an example of how you can use domain names with network sets. We are on top of the hour. I have still a few examples that I'm going to run through, maybe run 10, 15 minutes over. So stick around if you have time. I will go through the questions now before I move forward. So there is a question, can you manage manually policies via kubectl and Calico CDL? Yes, you can. And I think you've seen me using kubectl to apply the policies for both types, just standard Kubernetes policy and Calico policy. The reason I'm using kubectl just because I'm using Calico Enterprise. With Enterprise, you can just rely on kubectl to manage both types. With open source, you have to use Calico CDL, Calico Control CLI to apply and manage Calico policies. For enterprise version, there is an API server that Calico provides that just simplifies all that management, and you can everything you can manage with kubectl. And there is a question, are stage policies enhanced version of dry run in CLI tool? To some extent, what the stage policies allow you to do is to still collect the flow logs. So the dry run would not produce you flow logs. The stage policies actually apply to the cluster, just watches the traffic moving through the policy and collects the information about it. And one way to kind of confirm that, let me see if we have packaged Kibana with Calico Enterprise, where you can take a look at the raw flow logs. So if we take a look at the last couple of hours in here of logs collected and look at the endpoints, I can expand any of these endpoints and take a look at all the info collected. So you would see some traditional information like source and destination IPs, the ports, but you also get the Kubernetes context, like the name of the pod, the deployment name, the namespace, the type of the endpoint, whether that's a workload endpoint or host endpoint. And you also get all the policies in the order they evaluated. So they are prefixed with the ordering number, how the traffic moves through, and how the evaluation happens. So let's say I think there are a few in a storefront namespace. Let's see if I can quickly catch this. There are, so let's see if for something like front end service, the policy, no, this one doesn't have it. Let's see one more if I can get that information that I'm looking for. Okay, I'm not cannot find the flow as an example, but the stage policies, they also capture it within these flows, so you can actually go and see the details when policy gets evaluated. So there is another question, just to confirm that network sets can be both whitelisted and blacklisted depending on the action attached to the network resource. Yes, that is correct. So if I take a look at the list in here, there is a, for instance, PCI whitelist, which has the rules. I don't remember if I have network set with the with those rules, but I can give you an example. Block fee auto. So there is another capability called threat feeds, which essentially the threat feed is a pool of the resource, and let's take a look into that as a next example. So let me remove some of the one of the policies so that I can give you an example. And so I have a global threat feed right here, and the way it's defined, you can manage a list of IPs or domain names somewhere outside and provide the access, like HTTP access to that, and you can either pull or push that list. So in this example, I'm using the publicly managed Fiodo tracker, and if I go ahead and open this up and grab one of the IPs in this list, and then ping this IP. Let's see, I have an example for this. And it looks like there is, I have a policy that is blocking it. Oh, okay. So I have a thread feed Fiodo right here. So I have a policy that pulls this, and I have a thread feed Fiodo label on the this is network set, on the network set. So if I jump and take a look into the policies that I have defined and look into the block Fiodo, you can see right now it applies to 45 endpoints. And what it does in here, it says deny any traffic to a thread feed Fiodo. So you can deny the traffic in there. So let's just to show you that I can exclude this. Let's change this to not in and change this to default. Apply the label, exclude a few endpoints. Oh. So now I have 42 endpoints. Let's try to access that one more time. So now you can see I excluded my endpoint from blocking it. So now I can access that. So one more thing that I wanted to show is global alerts. That's something that Calico can provide you with alerting when something happens and you have alerts defined to capture that. You can see over the time as I was going through the demo scenarios, I got 7 different alerts. So if I jump to my alerts dashboard, you can see I got suspicious IP detected. That's because threat feed, once you try to access something that is added to or defined within the threat feed, that is considered as a suspicious activity. So my pings to these addresses produced several alerts. I also have alert defined for DNS logs, watching for someone going to Apple.com. So if I jump and take a look at my alerts that I've defined, and these examples are a part of the GitHub repo, you can see there is a template for the alert that watches for anyone trying to access apple.com domain. And if there is an entry, then alert gets triggered, and that's how I'm getting this in here. And also another example for watching audit. If someone is trying to change the resources that they are not allowed to, or if there is a burst of changes within very short period of time, that can be very suspicious. So you can define an alert to watch what is happening. Right now, for the purpose of this example, any change to global network set would produce such an alert. There are a few more examples, like the compliance reports, and there is an example for anomaly detection. Because we ran out of time, I'm going to leave this to you, and who's interested can go and check this examples running on your own. You can always get a Calico Enterprise trial to get a cluster with the Enterprise edition in there without spending too much time on setting that up yourself. For additional resources, you can go to docs.projectcalico.org, or for enterprise version, that's docs.tigera.io. And the link to the repository with demo examples is in here. The slides will be sent to you after the session. Thanks for attending. If you have any more questions, I'm going to leave it another minute and review some of the questions in the chat. There's a question, the community version doesn't have web GUI. That is correct. The community version does not provide any GUI. There's a question, can you log and deny at the same time? Let me show you an example for this. Yes, you can. And the quarantine policy is an example of that. You have a log action and then deny that traffic. So in that case, you would get your attempt or intent logged and then would drop it right away. That seems like all questions. Thanks for attending this session. Have a good one.